Edexcel called pure, complex numbers 4, de Moivre's theorem. Powers of complex numbers in the form x plus iy. So here we have the problem of raising 1 minus 1 over root 3i to the power 4. And before we can do that and take advantage of de Moivre's theorem, we need to get this complex number into modulus argument form. So we've been given a component form and we need to get to the modulus argument form. So the first thing we need to be thinking about is the modulus of this number. So the modulus, or r in other words, so we're doing Pythag on the 1 and the 1 over root 3. To get 2 over root 3. We also need the argument, in other words theta, and before we can get to theta it is well worth just sketching this complex number just to make sure we know what it looks like and we get the correct value of theta. So we've got a real axis, imaginary axis, and 1 minus 1 over root 3i is approximately there. This is the angle theta that we are looking for. So in that quadrant I can do arc tan the y coordinate divided by 1 for the x coordinate, and that will give me the correct angle of minus pi by 6. So there's the modulus and now the argument of the complex number. So we can now go away from the component form which we've been given and go to the modulus argument form. So it's r bracket cos the principal argument which we've correctly found as minus pi by 6 plus I sine minus pi by 6. Now we've got everything in the right form. We can raise it to the power 4. So applying de Moivre's theorem, we've got 2 over root 3 to the power 4 times cos of 4 times the argument plus I sine 4 times the previous argument. So when we work out the new modulus, we get 16 over 9, and you may choose to simplify these angles a little bit, although your calculator would clearly work them out. So I'm just cancelling them down a little bit to minus 2 pi by 3, and then with or without a calculator we can get this back into component form as minus 8/9 minus 8 root 3 over 9i. So that's what the answer would look like if you wanted to leave it in modulus argument form with a principal argument of minus 2 pi by 3, or we can very quickly turn it into the component form. So the things to be aware of when we went from the component form to the modulus argument form was the sketch was very useful, particularly in identifying that negative pi by 6 as the principal argument. And don't forget you've got to raise the whole of the complex number to the power 4, including r. So now we are going to raise 2 plus 2i to the power 5 and give the answer in a component form at the end with exact values. So the first thing I want to know is the modulus of this complex number, in other words r. So Pythag will give me that value, and we get 2 root 2. So we've got the modulus, or the value of r. We also need the argument, or theta, and again a quick sketch real axis, imaginary axis, 2 plus 2i is approximately there, and that point there is 2, 2, and we can almost read off what theta is from the diagram really, if you think of this as an isosceles triangle. But you can also trust your calculator here and do arctan the y over the x, and arctan 1 will be pi by 4. So we now know what 2 plus 2i is in modulus argument form, so I can write it as 2 root 2 cos pi by 4 plus I sine pi by 4. So that's the modulus argument form, and we have to raise that to the power 5. So applying de Moivre's theorem, we will get 2 root 2 to the power 5, and cos of 5 times pi by 4 plus I sine 5 times pi by 4. Again, we could work these out on a calculator, but if you were going to leave them in this form, we've got to be careful with the modulus argument form, because 5 pi by 4 is outside the principal range. So to get this back into the principal range, we could simply take 2 pi off these angles, these arguments. So if you wanted to leave it in mod argument form, you would need to take off 2 pi from these angles, so that would be minus 3 pi by 4 plus I sine minus 3 pi by 4. So that's only relevant if you're going to leave the answer in that form. You could of course work these out on a calculator. So we're going to go to component form now. So 2 root 2 to the power 5 is 128 root 2. And cos of minus 3 pi by 4 is minus 1 over root 2. And sine of minus 3 pi by 4 is minus 1 over root 2i. So we don't particularly need the brackets here. We can write the answer as minus 128 is the real part, minus 128 is the imaginary part. So there's the final answer in component form, and this would be the answer if you wanted it in mod argument form. So to summarize the key details, we need to take this component form, we need to find its modulus, which is 2 root 2, so that's R, its modulus. We also need to know its argument. If you've got any doubts about the principal argument, go into a quick sketch. We'll just confirm whether you've got the right angle or whether it needs to be adjusted appropriately. Once you have found the modulus argument form, don't forget that it's the whole of the complex number that's going to be raised to the power 5, and it's that raising it to the power 5 is when you can use de Moivre's theorem to multiply the argument by 5. So there's the answer in component form. In the next video we're going to be looking at using de Moivre's theorem.